This is question 20 from the second CSAT sample paper. In this part, we're just asked to show that 3 to the 33 is strictly greater than 2 to the 50. So if you want to have a go at this part yourself, pause the video now. Okay, so how should we approach this? Obviously these are too big to calculate, so we've got to break them down. So the best thing to try is probably to look at powers of 3 and nearby powers of 2 that they're greater than, and then start, say, squaring or multiplying those to try to reach this inequality. So something that looks like a nice place to start is that 3 squared is greater than 2 cubed, 9 is greater than 8. So maybe we could use those and start multiplying both sides. So we could do, say, 9 to the 16 is going to be 3 to the 32, that would be close to this, and we could compare to 8 to the 16. But that turns out it doesn't quite get you this inequality, which I think is why they chose these numbers. So you have to do more work than that. So we'll have to look at a different power of 3. So the one I chose first was 3 to the 6. So it's easy enough to calculate because it's 9 cubed, which is 9 times 81, which is 729. The main thing I care about is it's bigger than 700, so why do I care about that? Well, what powers of 2 do I know? It might be useful for you to know, especially if you're a computer scientist, 2 to the 10 is 1024. And this is 2 to the 10 to the 5, so if we can compare to 2 to the 10, that would be good. And the main reason we remember 2 to the 10 is because it's just larger than 1,000, so we can compare powers of 2 to thousands. And the reason 700 is nice is because if I multiply this by 3, I get something just a bit bigger than 2,000. And 2,000 is going to be close to 2 to the 11. So in particular, if I do 3 to the 7, from here I now know that's bigger than 2,100. And that's going to be bigger than 2 to the 11, because 2 to the 11 I just get by doubling this, which is going to be 2048. So it's going to be less than 3 to the 7. So maybe now I've got this power of 3 is bigger than this power of 2. Bear in mind we want powers that are quite close, otherwise we can't get to this inequality from them. If we know this relationship, perhaps we can get from here to here. So what should we do from there? Well, I want to first get to something close to 33 than 7. So let's say I do this to the power of 4 and this to the power of 4. So I'm multiplying 7 by 4 and 11 by 4. And I get 3 to the 28 is greater than 2 to the 44. And now what I want is for 3 to the 5 to be greater than 2 to the 6, because then I can multiply this by 3 to the 5 and this by 2 to the 6, and I'm guaranteed for the left-hand side to be bigger than the right-hand side. So, is this true? Well, yes, because 2 to the 6 is 64, 3 to the 5 is going to be 3 times 81, which is over 200, so this is much bigger than that. And therefore we can claim, we can multiply these two sides, the answer is definitely bigger than this side, so definitely 3 to the 33 is bigger than 2 to the 50 as required. Let's just quickly mention another method. Well, one method that looks promising but doesn't work is you can do a binomial expansion for the left here. So you can call this 1 plus 2 all to the 33, do a binomial expansion and compare terms. But it turns out you have to do a lot of working out, as far as I can see, to compare this side to this side. So that's not a good approach. So I've written out another approach that I think actually requires less working out, but a little more thought. So another way of approaching this is thinking maybe I can try and reduce the powers, and like I could do the 5th root of both sides. So that's dividing both powers by 5. So this becomes 2 to the 10, which is good because I know that's 1024. And this side becomes 3 to the 6.6, which doesn't immediately look promising. But if I could show that 2 to the 10 is less than 3 to the 6.5, then this is less than this, and I'm done. And why is this good? Well, because the 0.5 is basically a root 3, so this is 3 to the 6 times root 3. Or 9 cubed times root 3, and I know 9 cubed, so it's easy to work out, so 729 root 3. And I know roughly the size of this. I know at least it's bigger than 1.7. This is bigger than 700. So if I multiply these, I get something bigger than 700 times 1.7, that's easy to work out. 7 times 1.7, so we get 7 plus 4.9 is 11.9 times 100. We get 1,190. That's definitely bigger than 1,024, which is 2 to the 10. So therefore 3 to the 6.5 is bigger than 2 to the 10, which is exactly what we needed to show this. So this is another way of answering the question.